Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 3885. It's a contest. Second questions we have today is design event manager. The question saying that you are given an initial list of event where each event has a unique event ID and a priority. So you have to implement this event manager class. You have given methods, this event manager, in which we will pass the 2D grid of events. So it initializes the manager with the given events. The events at I is nothing but event ID and the priority grid, a priority value, we can say that the event and its priority. Then we have to update right through the event and its new priority. So if existing event we already have and we are going to set the new priority, it means we have to use this priority, okay, and we have to replace the new one. Again, we have the poll highest where we have to remove and return the event which is active on the highest priority. Okay, this is what we have given, and this is the example we have, as you can see here. Okay, so let's think that we have given the event, let's suppose like this, right? And what is it saying that, let me think, let me go through with the statement here. Okay, here, so let's suppose that we have given a event like this. So let's suppose I'll take a event, right, and we can represent this event in a array. Okay, so each index we have given, right, like this, right, and each index, or we can say give me 1 second, let's suppose we will directly write 1 5, the very first event we have. Then we can write like 2 5, we can say that, and 3 3. Let's suppose if we have the event like this, right, so basically you will say these events, right, so these events will contain in a list of event like this, right, so this become 2D grid, right? So for now I will remove this thing, so just for understanding I'm saying. Okay, so think that this is our events we have given. Okay, now the question is, who gets picked first? If you see here, who gets picked the first event here? Okay, so think that what should be our answer? The answer should be 1, the very first, having the same priority, we can say, right, with the smallest ID, because here we have two priorities having the same. We have these 5, right, and these 5 I'm talking about. So but the priority, if you say priority wise, if you say, so when we update or when we store, right, the events at I is having event ID and the priority ID, right, the event ID and the priority. So the smallest priority, if we have the same priority we have, right, if we have the same priority, it means we should use the smallest ID. Okay, we'll say ID, smallest ID we should use. Gotcha? So the answer is 1, means this one. Okay, now you understand this, right? Now think that we have a problem that is already set, right, and if we want to pick the highest priority, we have to break down with the smallest ID, right? Now think that how we will solve this type of problem. Basically, if you try through the naive approach, means it will fail. So what you should do here is, you should, if you will try with the linear scan, right, and if you try with that, let's suppose the what I am trying to say is time complexity become is what, O of n per query. Queries like we have given, these are the queries we have given, right guys, right? Per query it will give O of n as a time complexity due to the linear scan, we can say that, correct? So better to use what? Heap map, right? So what I'm trying to say, let's suppose that understand the max heap concept. I hope you understand. So let me introduce this max heap. Okay, so the thing we have saw, if we'll represent that in a tree, how we can represent, the very first we have seen is 1 5. So 1 5 is a root, then we'll say is 2 5 came and 3 3 came. If we'll represent like this, so you know the answer is the what, the top, right? 1 5, right? So if we want to update this problem, right, so what we can say, if we want to update the priority, let's suppose we want to update, right? So when we are going to update, we have to pass the event id, right? It is 1, and the priority here. So let's suppose we'll pass the priority 10. Means now the one has the priority is 10. Previously it was 5, correct? If you see here, the priority was what? How much is 5 here, correct? But the new priority that we are going to set is 110, correct? So we can say that this is what we have given. Okay. Now the old node is, it should be updated, right? How much it will updated? It should updated with 1 and 10, like this. So when 1 and 10 will come, what will happen? The heap become little messy, and we'll say, okay, now we'll remove this one and we'll say messy. How will this become? Because this is not the way, right? If 110 is there, right? So and heap contains 1 5, right? Because we are updating it. So when the old node is there, 1 5, right? The new node got was is 110, right? So the new node 1 is inserted here right now. So the previous was what? How much? 1 5, right? So this time he become messy, and it will say, okay, do the lazy deletion. Why we will not delete directly here? I will update because this is heap. You know the tree, right? Right. So in the tree concept is that you have to do lazy deletion. This is the core magic of the problem, right? Where what you will do, you will pick here now is, let's suppose 110. 110 is there. So we'll return it and we'll skip this part because this is the next pick we have. The next pick we will skip. If you want the next one, so we'll get, basically I want to say, okay, okay, let's suppose that we'll very first pick how much is 110. So we will return this answer. Okay, let's suppose we want the next pick. What should be the next pick? So next pick become what? 1 5. But this we have to skip. Okay, then third would become what? Next. What is the next element? Next pick element, we will say 2 5. So we can use this one also. So skip, we have to skip the outdated entries that is not required right now, right? And then so the 1 become with the 10, 2 become with the 5, and 3 become with 3 as updated nodes, right? So the heap become messy, but it's faster, okay? Because heap lies between the map concept as a truth, right? That tells the truth what is map like this, okay? So the very first is you should implement the heap. So initialize with the heap building, okay? Very first concept, do the building, okay? Then you have to update, means you have to push the new one. Then what you need to do, you have to poll. When you will do the poll, you have to skip the invalid one, okay? And then you will return the latest one that you have updated, okay? In this way, what will happen is when you will do the update, it will take off log n. which is better than before. If you do even the poly you will do, it will give the O of log n. So this gives you the great thing to solve this type of problem. Okay. So let's try to understand how we are going to implement. Okay. The very first thing is that we should understand the problem. So this is a system design problem, okay, where you have to build something, right, called real-time event. Okay, so this is a real-time event scheduling system, you can say that, scheduling system. This is completely based on that. So what you need to do, the very first is that you will add the event. Okay, the very first functional requirement is add the events. Okay, when you add the events, then the functionality should also be have is update priority. Once you will update the priority, you will say what is the get the highest priority events, and the fourth one is you have to remove after processing, means the lazy deletion. So these are the concept or the functionality you have to update in this system design. Okay, so the high level, if I'll talk about, is how we'll implement this. So we can say that, okay, there is a client who want to call the event manager service, right? So there should be some data structure that should handle the data structure. So choosing the right data structure is very important. So the core data structure that we should use is nothing but the max heap, where you can do the fast retrieval, guys, fast retrieval. Okay, and maintain order, right, easily. Then the concept is also you should use what do you call has map. You should use is has map, where you will store the latest information. Why will you use store the latest state? Store the latest state, you can say, and it also prevent inconsistency. Okay, that is the concept of has map. Okay, I know you're aware with that. Once this is done, right, so you are able to do these steps, right? Now what you should do is, what you need to do is, when you're going to create add event, right, how will you do the add event? When you do the add event, you directly insert into heap. Okay, and the map also. So when you're adding the event, you have to insert into the heap and the map. Okay, when you updating that, you have to, when you update the map, push a new entry, push new entry. So what will happen when you push a new entry to heap, right? What will happen? The old one becomes stale. Okay, so also old entry becomes stale. When you will do the poll event, then what will happen? Check the top element. Check the top element. If it is valid, return. Otherwise, discard. So these are the functionality, guys, as a system design you should understand, and you can talk to the interviewer as well. So let's see how to implement. Okay, okay, the very first is you should use a map. As I told you, map contains key and value pair. Then you will to use the max heap. In the max heap concept, there is a priority queue. So priority queue will contain a list of integer, that is called array, you can say that. Okay, array of elements, you can say that, right? So means priority data, you can say priority data you can store. So the max heap we will use for all these given events. How? Very first you will initialize this data, and based on the higher priority you have to use this, it is called comparator. So two event, let's suppose event A and event B is there. You will check if event B1 is not equal to A1, means both event is not equal. In this higher priority we will return B1 minus A1, you can say B at 1 and A minus 1, means the priority of B minus priority of A. So you will get the highest priority one, because this is the comparator will do the sorting. Basically this part of will do the sort the order. Okay, then you will return A0 minus B0, because A at 0 minus B at 0 is it will give you the smaller events. So if you do B at 1 minus A at 1, means you will get higher priority. But when you return a smaller one, so you have to do A at 0 minus B at 0, means event you need is a smaller, but priority you need is a higher, means you need a custom comparator. So this custom comparator will do the automatic sorting and it will return the data. Okay, then over the events, what you need to do is you will get the ID at the each entry of the events, from where you will get the event ID and the priority like this. Okay, so very first you will put on the map. So this ID and priority based you will keep adding. So this is the lowest priority, because the smallest priority based on we have did the smallest priority and the highest, no sorry, smallest ID and the higher priority you will keep adding onto the map, right? And then you will do the max heap dot offer, means you will also add onto the heap. So max heap dot offer means you want to add as a array of pair elements, and this array will store as a one pair as a ID and priority. Once this is done, so you need to create a update functionality, right? I'll go with here. So you have already added the priority ID and priority, event ID and priority on the map, and the heap also contains many pairs like this. So combination of this ID and priority will be there in the max heap. When you want to update the priority, you want to pass the event and the new priority. Very first check on the map, it is on the map, return. Ignore it, because if it is not on the map, means we don't need to update the priority. But but if it is on the map, you just need to use the same event and priority. So you know that what map will do, map will automatically will remove the old entries from the map, and it will store the new entry. Then you will do what? Max heap dot offer, where you will add as a new entry. But what will happen, it will do the lazy insert. Very first it will insert as a new entry, and old one it will delete automatically. So that will happen in the background, so you don't need to worry about that. Now think about the poll. Okay, so deletion part in both concept, right? Either in the map and the max heap, both will happen automatically. You don't no need to care about that. In Java will handle that. Now we have poll highest. In that concept, what will happen, you will check, okay, max heap is empty. Is it empty or not? If it is empty, so very first what you will do, you will poll that concept max heap dot poll, and you will get the top. Then you will have int id equal to top, right? You will got the top of 0 and priority. So you will get the top element, you will get both the top and priority. Now you will check if it contains in the map, because you have already polled. Then you will remove the id, you will mark it as a inactive, because you have already you have to delete from the map, because you have done poll. So you will get from the max heap, that is fine. You will do you will remove from the max heap, but you also have to remove from the map. So you will do from here, and finally will return -1. This is what we have in this video, guys. In case you have any doubt, Let me know in the comment section. Okay, what we have done here, we have done to create map and max heap. And very first we have created a comparator. We have stored through the smaller id higher priority, then we have iterate over the events, we have put on the map and the heap, then we have updated the priority. If not contains on the map, return inactive, otherwise delete, update the max, update the from the map and the max heap, right? And then if you want to do poll, very first get the elements right on the id and priority, and then remove it from here. This is what we have, and when we are doing the poll, you have to return the id. So that's all in this video, guys. In case you have any doubt, please ping me in the comment box, and thank you for joining. And if you like this video, please hit subscribe this channel, and any suggestions is welcomed. Please do write anything you have. And if you want to do the structured way of learning, you can join my online classes. For that, you have to connect with me through the WhatsApp. Thank you so much. Stay healthy, stay wealthy, and that's all I have in this video. Thank you so much.